Good morning, my dear students. Today I am going to start the third unit, that is linked list. We know already we discussed various types of array implementations using queue, circular queue, double-ended queue, and priority queue, and stacks. So these are all under second unit. So linked lists using pointers, we will implement stack data structures, queue data structures, single linked list, double linked list, circular linked list, etc. We will implement using pointers. So in the unit 3, these are the contents: pointers, pointer arrays, linked lists, node representation, single linked list, traversing and searching a single linked list, insertion into and deletion from a single linked list, header linked list, circular linked list, double linked list, linked stacks and queues, polynomials, polynomial representation, sparse matrices. These are the contents under third unit. Today we are going to discuss pointers, pointer arrays, and linked lists. Introduction to linked lists. Clear all of you? Then today, so pointers. What is a pointer? Pointer is a variable which holds the address of the another variable. Pointer is also a variable which holds the address of the another variable. That is called pointer. Simply, a pointer is a variable whose value is the address of another variable. A pointer is a variable which holds the address of the another variable. This is the definition. Pointer is a variable whose value is the address of another variable. That is direct address of the memory location. That is direct address of the memory location. Like any variable or constant, you must declare a pointer before using it to store any variable address. The general form of a pointer variable declaration is type asterisk variable name. In pointer concepts, there are two operators playing major roles. In pointer concepts, there are two operators playing major roles. The first one is called ampersand operator, and the second one is called asterisk operator. The first one is called ampersand operator, and the second one is called asterisk operator. Here simply the ampersand operator is used to show the address of the variable. Show the address of the variable. Then asterisk operator, it is used to show a value into a particular address location. So one is the indirection operator, another one is indirection operator. Reference operator, another one is indirection operator. Reference operator is an address, then the asterisk is an indirection operator. All of you, a pointer is a variable whose value is the address of another variable, that is direct address of the memory location. Like any variable or constant, you must declare a pointer before using it to store any variable address. The general form of a pointer variable declaration is, this is the type asterisk variable name, asterisk prefixed with the variable name. Clear? So then type asterisk variable name, integer asterisk p, it is an integer pointer variable. Here asterisk ip, this represents or this indicates or this identifies. This is a pointer variable. The data type is integer. It is also occupies 2 bytes. Clear? So then the next example is double Double asterisk DP. Double is also a data type. Asterisk DP is a pointer variable. Clear? Asterisk DP is a pointer variable. So then the data type is double. Next one is asterisk FP. It is also a pointer variable. The data type is float. Asterisk CH. It is also a pointer variable. The data type is character. Clear all of you? How to declare a pointer variable? So this is a pointer variable. Pointer variable refers to a value in the address or memory location. So this is an example for using pointers. So this is the hash include stdio.h standard input output header file. Then main function. Every C program should have one function that is called main function. Declare a variable integer var equal to 20. Here integer var equal to 20. So var is a general variable. It is a general integer variable. Integer asterisk IP. Integer asterisk IP. It is a pointer variable. IP is a pointer variable. Where pointer variable equal to ampersand var. Var is a general variable. So ampersand. This is an address operator. So var address assign into IP. Variable address assign into IP. So with the help of ampersand operator, ampersand var means so the address of where assign into IP. Now what is the value of IP? Address of variable. Already I told. So then what? A pointer variable is a variable which holds the address of the another general variable. Clear? Another general variable. IP is a pointer variable. It holds the address of the general variable var. Clear? So then print address of variable percentage x. This is address. Next one print address of same IP value equal to address of variable. Then print the value of I equal to asterisk IP. Asterisk IP shows the content into a variable address, that is 20. So that's why this is called indirection operator. It shows the value in the address location. Which address location? Where address location. Asterisk IP. It shows the content or it collects the value from the variable address. What is the value in the variable address? 20. Clear? Then return 0. This is an example program for simple pointer declaration. How to assign the address to the pointer variable. How to display the address of the variable. How to display the value of the pointer variable. How to display the content into a address location. Then these three statements are examples. Clear? Next one, null pointer. NULL, null pointers. It is always a good practice to assign a null value to a pointer variable in case we do not have an extract address to be assigned. Clear? This is done at the time of variable declaration time. So this is a good behavior to assign null to a pointer variable. Clear? A pointer that is assigned null is called a null pointer. NULL, null pointer. Clear? The null pointer is a constant with a value of 0 defined in several standard libraries. Consider the following program. Integer asterisk ptr equal to null. Integer asterisk ptr equal to null. Here printf, the value of ptr is percentage x ptr. Clear? That is the 0 value displayed. Clear? What is null? ptr value null. Display null value, that is 0. Clear all of you? This is the null pointer. How to assign null pointer? So remember this one. Later we will discuss in clearly. So in single linked list, double linked list, stack using pointers, stack using queue using pointers. Okay. Then here null pointers. How to assign null pointer? Null integer asterisk ptr equal to null. Clear? Next one, advantages of pointers in C language. Advantages of pointers in C language. Pointers are useful for accessing memory locations. Am I right or not? Yes, that is one of the advantages. Pointers provide an efficient way for accessing the elements of an array structure. Pointers provide an efficient way for accessing the elements of an array structure. So we want to more elements, then that is called array structure. So the pointers provide the best facility to access array of elements. So pointers are used for dynamic memory allocation as well as deallocation. So pointers are used for dynamic memory allocation as well as deallocation. While using pointers, we will allocate the memory at a program execution time, that is called dynamic memory allocation. At a program execution time, as well as deallocation at the same time, we want to release the same space. Again, we can use the same space in another program also. Whereas in static binding, whereas in static allocation, so deallocation is not possible. Clear? In static allocation, integer a of 10, that is fixed, that is assigned. But is it possible to reuse? No. Whereas in a dynamic allocation, dynamic memory allocations, then there are some functions available. Dynamic memory allocation functions, malloc, free, malloc, calloc, realloc. These three are the memory allocation functions, and free is a memory release function. Once occupied memory, the free function is released. Clear? Pointers are used to form complex data structures such as linked list, graphs, trees, etc. So these pointers are used to form complex data structures such as linked list, graph, trace, etc. So next concept is array of pointers. It is collection of addresses or collection of pointers. It is collection of addresses or collection of pointers, that is called array of pointers. So what is the declaration, the general syntax and example of the array of pointers? The following is the declaration of for array of pointers. The data type, the same previous examples, that how to declare a pointer variable. Data type, asterisk, pointer name, then the size of the array. For example, integer asterisk p of 5. Here p is a pointer variable. How many blocks allocated? 5 blocks memory allocated to pointer variable. It represents an array of pointers that can hold 5 integer element addresses. Clear? So then initialization of an arrays. Initialization of an arrays. So ampersand is used for initialization. Am I right or not? Why? So the variable address assigned into pointer variable. That is the value of the pointer variable. Here ampersand used for initialization. It is an address operator. So in this example, integer a of 3 equal to 10, 20, 30. So it is a general declaration. It is a general declaration. So a of 3 array, integer array, 3 elements assigned into array. Next one, pointer declaration, asterisk pointer array declaration, array of pointers. Asterisk p of 3, 3 blocks memory allocated to pointer variable. Then I value 0, 0 less than 3, condition is true. P of I, pointer array equal to general array first location address assigned into pointer variable, that is first location of the pointer array. So P of 0 equal to, so then P of 0 address. Clear? Then I plus plus I1 equal to this one. Then again P of 1 equal to ampersand A of I. Second memory block address assigned into pointer variable, pointer array, second block. Then the next one, third block, memory address assigned into pointer block, third block. Clear? So then, so this is called, so R, P of I equal to ampersand A of I, or P of I equal to A plus I, where A shows the base address of the array, I shows the number of blocks. For example, if it is I value equal to 0, initial value 0, for example, the base address, assume, we can assume 100. 100 plus 0 equal to 100 assigned into P of I location. In the next location, 100 plus 1, I value incremented by 1 itself. That's why 100 plus 1, 1 means 1 block. What is the block size of the array? 2 bytes. 2 bytes, 1 not 2 bytes. Then the second address assigned into second memory, pointer second memory location. Then the next one, I plus 2. that is equal to 4. 104 assigned into this memory location. Clear? This is an initialization of an addresses into pointer array. Clear? Next one is accessing. How to accessing? So indirection operator asterisk is used for accessing elements. Accessing elements. For example, I equal to 0, I less than or I less than 3, I plus plus here semicolon. For example, I equal to 0. I equal to 0. I less than 3, I plus plus, print a percentage the asterisk P of I. So here asterisk P of I means what is the value in the pointer address location, pointer array address location. Clear? So what is the value of I? That is the address of the general array. Clear? So it is collected. It is used to collect a value from the A of I array, A of I location. Clear? This is accessing all of you. For example, for I is equal to 0, I less than 3, I plus plus. Then display first value, second value, third value. That's why asterisk is called an indirection operator. Tomorrow I will use word and explain each and every point. Clear? Pointer, how to access pointer variables. Example program. So here integer A of 3 equal to 10, 20, 30. These three values assigned into array. So this is a general array. It is not a pointer array. Remember. Next one, integer asterisk P of 3. So this is a pointer array. Declared array of pointers. Then for I is equal to 0, I less than 3, I plus plus. Assign each general array memory location address into pointer array. So each pointer P of I value equal to, that is an address of A of I. Clear? Print up elements of the array. See all of you. I equal to 0, I less than 3, I plus plus. Your percentage is slash t asterisk P of I. So first display 0, 0 location value equal to 10. Then display P of 1, that is P of 1 address location value equal to 20. Next one P of 2, 30. Display all the elements from array. Okay, all of you. So this is an output. All of you. When the above program is executed, it produces the following results elements at the array are 10, 20, 30. Tomorrow I will use Blackboard. I will explain with the address locations. Clear, all of you? Okay. Next one, linked list. What is a linked list? So what are the types of linked list? How many ways to represent linked list? So what are the operations on linked list? Linked list is a linear data structure which consists of group of nodes and each node represents one data element. Unlike arrays, linked list elements are not stored at contiguous locations. The elements are linked using pointers. For example, our Indian government, Indian Railway government want to create a special train. So special trains, for example, in Vijayawada. So compartments, they want to collect 10 to 20 compartments, but all the compartments are not available. So, but compartments available in various stations. First of all, they want to collect first compartment, second compartment, third compartment, and so put a link between first and second compartments. Clear? Here also the same. In a linear data structures which consists of group of nodes and each node represents one data element. Unlike arrays, linked list elements are not stored at contiguous locations. In arrays, contiguous memory locations, but whereas in linked list, there is no contiguous locations. The elements are linked using pointers like compartments. Clear? So example, the following is a linked list with 10, 20, 30 values. Each value in a separate node and start is a pointer which points to the first node. Start is also called as a head node. This is online bit. Start is also called head node. Then how many nodes are there? 3 nodes. Each node how many parts? two parts. First node 2 parts, second node 2 parts, and the third node is also 2 parts. Here start, this is called header node. Start is also called header node. This is value. Then the next part, it shows the link, means this address assigned into this memory location. So that is called link. Then the second node, this is the value, this is the address of the next link. So then there is no link, that's why I assigned null. Clear? These three are the nodes connected between nodes. Clear? This is called linked list. What are the advantages and disadvantages of linked list? Advantages and disadvantages of linked list. Advantages of linked list. They are a dynamic in nature which allocates the memory when required. Insertion and deletion operations can be easily implemented. Stacks and queues can be easily implemented. Linked list reduces the access time. Linked list reduces the access time. Increase the fast. Clear? What are the disadvantages of linked list? The memory is wasted as pointers require extra memory for storage. No element can be accessed randomly. It has to access each node sequentially. Clear? These are the advantages and disadvantages of linked list. He may be asked in 2 marks question, what are the advantages and disadvantages of linked list? Then applications of linked list. What are the applications of linked list? This is also 2 marks question or 3 marks question. Remember all of you. Applications of linked list. Linked lists are used to implement stacks, queues, polynomials, sparse matrix, graphs, etc. Clear? Linked lists let we insert elements at the beginning and end of the list, anywhere of the list. In a linked list, we don't need to know the size in advance. In a linked list, no need to define the size in advance. Clear? So then these are the applications of the linked list. What are the differences between arrays and linked lists? What are the differences between arrays and linked lists? Okay, all of you. So definition, array definition and linked list definition. An array is a collection of elements having same data type which common name, that is called an array. An array is a collection of elements having same data type which common name, that is called an array. Linked list, this is the first difference. Linked list is an ordered collection of elements which are connected by links or pointers. This is the first difference. Definitions are the first difference. Next one, access. In array, elements can be accessed using index, subscript value, that is element can be randomly accessed like array of 0, array of 1, array of 2, array of 3, etc. So array provides fast and random access. So in a linked list, elements cannot be accessed randomly, but can be accessed only sequentially, and accessing elements takes order of n times. Clear? So the next difference is memory structures. In array, elements are stored in consecutive manner in memory, continuous memory blocks. Consecutive means. In a linked list, elements can be stored at any available place as address of node is stored in previous node. Put a link between present node and previous node. Insertion and deletion operations. Insertion and deletion takes more time in an array as elements are stored in consecutive memory locations. Whereas in linked list, insertion and deletions are fast and easy in linked list as only value of pointer is needed to change. Then memory allocation. In array, memory allocated at the compile time, that is static memory allocation. In a linked list, memory allocation allocated at runtime, that is dynamic memory allocation. That is dynamic memory allocation. So extra space. In array, no pointers are used like linked list, so no need to extra space in memory for pointers. Whereas in linked list, adjacency between the elements are maintained using pointers or links. So pointers are used for that extra memory space is needed. So extra memory space is not allowed in the arrays. Extra memory space is allowed in linked list. So this is also 2 marks or 5 marks question, all of you. Differences between array and linked list. Clear? 6 points. Remember all of you. And next one, types of linked list. What are the types of linked list? Single linked list, double linked list, circular single linked list, circular double linked list. These are the types of linked list. Tomorrow we will discuss each and every linked list. Okay, ma? Good. Thank you.